Good morning, folks. Happy Monday. Today's target is to convert the number of moles and liters of a substance. So, in order to do that, there are two vocabulary terms that we need to talk about. The first is STP. Remember, anything that is written on the board or that I write on the board, I will want you to write in your notes. So take this opportunity to write notes, grab a pencil, and follow along with me. Okay, STP stands for Standard Temperature and Pressure. Okay. So why does STP matter when we're converting moles and liters of a particular substance? Well, it really matters for gases. See, things like solids and liquids, we can very easily find their masses using a triple beam balance. But it's not like I can just take the air in this room and put it on top of a triple beam balance. It's very difficult to measure the grams of a gas. But it's relatively easy to measure the liters of a gas. I can take a syringe and I can fill it with gas. I can fill an oxygen tank with oxygen and I can learn how much oxygen is in that tank based off of its volume. However, gases can change in volume. So if a gas is going to get hot, like in a hot air balloon, that gas is going to expand. If you were to take a balloon filled with air and stick it in a freezer, it would actually shrink because gases' volumes change based off their temperature. So for all the problems that we're working with, we are going to assume that our gases are at a standard temperature, or 0 degrees Celsius. We're also going to assume that our gases are at a standard pressure, because if a gas has a lot of pressure exerted on it, it can be compressed into a smaller space. Likewise, if a gas is underpressurized, it can expand to fill up a much larger space. So what is the pressure of our gas going to be? We're going to assume our gas is at 1 atmosphere of pressure, because that's a very standard amount of pressure for gases to be experiencing. After all of the gas surrounding us right now has 1 atmosphere of pressure pushing on it. All right, so what's the second vocabulary term we need to talk about? The second one is called molar volume. Molar volume essentially states that 1 mole of a substance or 1 mole of a gas, more specifically, 1 mole of a gas is equal to 22.4 liters of a gas. Okay. This is a very handy conversion factor. It does make some assumptions. It's assuming that our gas is at STP, and it's assuming that our gas is behaving like an ideal gas. The gas is doing things we would expect gases to do. However, using this conversion factor, we can convert the number of moles of a gas into liters of a gas, and we can convert liters of a gas into moles of a gas. It's really quite useful. We're going to go over a practice problem where we discuss how to convert moles of a substance into liters. Hi folks. Okay, so with this practice problem, we are going to convert 0.60 moles of SO2 into liters of SO2 using our molar volume conversion factor that we talked about in the previous problem. Okay, so how do I do that? Well, effectively, just like in previous problems that we were doing last week, we're going to multiply this by a conversion factor. We're going to multiply it by our molar volume. 22.4 liters equals 1 mole. All right, so which number is going to go on the top and which number is going to go on the bottom? Well, we need our moles to cancel out. So that means that I need to divide by 1 mole. After all, if I take moles divided by itself, my moles will cancel out. My 22.4 liters will go on the top, because I need my final units to be liters. And then all I have to do is take 0.6 multiplied by 22.4 divided by 1, equals my answer. When I punched these numbers into my calculator, I got 13.44. 13.44 liters of SO2. Cool. All right. Let's go ahead and talk about the reverse. How do we convert liters of a substance into moles of a substance? Remember, we're assuming that all of the gases we're working with are at standard temperature and pressure. So even though we're going to have a very specific amount of liters, those liters won't change. In this particular practice problem, we've got 8 liters of O2. So once again, we're going to multiply it by a conversion factor in order to figure out how many moles of O2 we have. All right, so we know there's 22.4 liters of O2 in 1 mole of O2. So what I can do is I can take my liters of O2 and I can put that on the bottom, and then my liters of O2 will cancel out, and I can put 1 mole of O2 on the top. So I'll take 8 times 1 divided by 22.4 equals the number of moles of O2 that I have. When I plugged that number into my calculator, I got 0.357 moles of O2. Cool. That concludes our lesson for today. There you go. See ya.